privilege, not a chore. And unconventional methods, common. I'm a teacher. I make more.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott. And if any of you out there want to speak with us or have one of your math questions answered, and you live here in Bakersfield, give us a call, 636-4357. If you're in San Luis Obispo, the number's toll free, 866-636-6284. You can even email us at dothemath@kern.org. You can watch online, dothemathonline.net, and we are all over social media, Facebook, Instagram, Twitter, YouTube. There are so many ways to get a hold of us. Give us a call. All
right, so we do have phone tutors available until 5:30. If you phone in, and as Scott said, if you would like to see your problem worked out on TV, simply let us know that. You'll automatically be going to the Kern County Fair if you do that. If you're calling from San Luis Obispo County and we do one of your math problems, you'll automatically get free ice cream, courtesy of Doc Bernstein's Ice Cream Lab. So, Scott, officially welcome to Do the Math.
Thank you.
Nice to have you on board. And why don't you let everybody know where you are working right now? So where do you teach at?
So I teach at Bakersfield High School. I've been there for 18 years, and I'm just kind of one of those crazy math nerd guys and seem to enjoy the heck out of this stuff.
Good.
So thought I'd join you.
We're glad to have you.
Thank you.
We have a special guest coming on in just a few moments. We'll be going live out to the ROC in a little bit to visit with our friends from Kern Schools Federal Credit Union. But before we do all of that, let's first take a look at today's Math in the News. So, famous sculptures that you have either seen personally or online or in movies, shows, things like that. When
almost
you think of
always
sculptures,
people, right? Almost always people. I think of sculpture, maybe even the bust of a famous president or something like that.
Right. Lincoln Memorial.
There you go. Right.
David.
Right.
What was that? Rodin, the thinker.
Right, that's a good one too.
Right.
I think, therefore I am, right.
So a lot of famous sculptures, and I found some, and these are rather unusual. So let's go ahead and take a look at the screen right here.
I have to agree with you.
As you can see, they're graphite. Now, this artist creates small sculptures. You need a microscope in order to see the details on these. They're carved from graphite rods. There are very few masters of this art because graphite is fragile and the process is time-consuming. Many of the projects take days to complete, are so tiny they're not measured in millimeters but microns.
Wow.
Now that's what struck me, all right, is because most of the students are probably going, yeah, those are pretty cool. I recognize some of these landmarks and famous buildings. But think about, I mean, the next time you're working in math class or any class and you've got your pencil out, just take a look at that. You know, how much of it is actually sharpened.
Right.
Right, the end of it, and how you could actually get something like that with that kind of detail on the tip of that.
Amazingly steady hand. You couldn't mess up.
I mean, the tools that you would need to use something like that, to make something like that, to produce something like that. But then I was like, all right, a lot of students will know millimeters, okay, and they know meters and things like that.
Right.
But microns, I mean, how often do we work with microns? So I figured, let's make that our math today.
Okay.
So here we go. How big is a micron? And there's the symbol for a micron. So when students see that, they'll know what that is.
How do you think you say that?
You can. So You can put 1,000 microns in 1 millimeter.
Wow.
So if you're measuring and you have 1 millimeter, you can fit 1,000 microns inside the 1 millimeter.
So 1,000 millimeters in 1 meter and 1,000 microns in 1 millimeter.
And you can see that a micron,
Wow.
household dust, bacteria, okay? So the bigger things, okay, the hair, right?
Yeah.
When you pluck out a hair,
Right.
when you take a look at that under a microscope, that's 100 microns
Wow.
in size.
Right.
Okay, that's 100 microns. And this guy is dealing in not hundreds of microns,
Right.
microns.
But in single microns.
Right.
Wow.
Spores, dust mites, viruses, these things like that. So I just thought it was interesting, a different unit of measurement
Right.
that a lot of students aren't particularly used to all the time. And that is today's Math in the News. Microns and how small they are. Simply amazing. Do you think you could make something like that?
No.
No? I don't think I could either. You know what? That'd be pretty difficult to make something like that. Now, Riley, you are in here visiting today, and why don't you let everybody know where you go to school and what grade you're in?
I go to Stockdale Elementary School, and I'm in 4th grade.
How's 4th grade?
Pretty fun.
Pretty fun? Well, that's good. Do you like the longer day? It's only 30 minutes more,
Yeah, only 30 minutes.
right? Guess what? When you go to 7th grade, what's going to happen?
Much longer.
It's gonna get
Much
There
longer.
you go. When you go to high school, what's going to happen?
Longer.
There you go, longer even. If you happen to go to college, what do you think is going to happen?
Oh, I'm going to college.
Oh, okay. Well, good. What do you think is going to happen as far as your time?
Longer. The school day is going to be longer.
It could be shorter,
Guess
but you're going to
what?
be
It's
putting
a
a
lot
lot of
shorter.
time
It
in
is.
because the number of classes you have may
Sweet.
not be a lot, but you'll be spending a lot of time on those classes.
Right.
But you'll be having a lot of fun too.
Yeah.
But you're having fun in 4th grade, right? What is the best thing, because you've been in school for a couple of weeks now, the best thing about 4th grade? And it doesn't have to be math, I know it probably is, but it could be something else.
Always being on the Acers.
Oh, you're always on the Acer, so you guys have laptops that you guys can use in your classroom all the time, right?
Yes.
So that is pretty cool that you guys are able to do that. Well, I don't have an Acer for you to work on right now, but we're going to make you work. Are you ready?
Okay.
Because I see you have the uniform on already, so we're going to put you to work. Why don't you head on over to the board with Scott?
Okay.
All right. Here's one of the problems from your math book, your homework. So
Okay.
let's go ahead and write this number up on the board.
Okay.
And why don't you start over on the left? So that way, if we need to, we can put some estimates next to these things.
All right.
253,495. 495.
Well done.
And now we will subtract. So if you want to listen to the number first so you'll know where you're going to be writing these things, 48,617. So 48,617. Now in your book it simply says estimate.
Okay.
So explain to us how you're going to do this.
You're going to go to the highest digit, and then you're going to look next door. If it's bigger, if it's 5 or more, you're going to add 1 more to the 2 and make it a 3.
Okay,
Good.
so go ahead and
Can you do that for
keep
the top
going.
number then? Where'd all the zeros come from?
You get rid of everything else.
Everything else
after.
becomes zeros. Gotcha. All right. Well done. I like it. What about the next one down?
It's a 4, and then the 8's next to it. It's bigger than 5, so you got to add 1 more to the 4.
Gotcha. So you're always looking at the very first number that you see?
Yes.
Okay.
For now.
Well done. So which one do we want to do first? How about the one with all the zeros? All right. Let's do it. Take a look back over here at your original problem. Look way over there. What do you see? What kind of a problem is this one?
Subtraction.
Gotcha. What about that one?
Addition, because
Yeah.
you need. Oh yeah, subtraction.
Subtraction. There you
Yep.
go. And get out your eraser there. We'll just do this. Whoop, whoop. That's pretty
There
close.
we go. That's pretty close.
Good. Okay, now take a look. Ready? Remember we had some subtraction, right? Okay, and tell me a little bit about subtraction. If you were going to do 5 minus 7, right? Can you do 5 minus 7?
No.
What would you have to do?
You would have to regroup.
Yeah, you have to regroup. So let's look back over here first. Ready? Can you do 0 minus 0?
Yes.
Yeah. Can you do 0 minus 5?
Yeah.
Uh-oh. Try again.
Oh,
Can you do
nope.
0 minus... Ah, nope. So let's try again. Well, I'm going to go ahead and erase this part for you right here. Okay? And let's have you try that last part again. There you go. Oh, I like what you did there. Now we're good. Go for it. Good. Nice job. Well done. I like it how you fixed that one. Okay, so what do you think? Why in the world do you do this in the first place? I mean, it's a lot easier with a whole bunch of zeros, but why are you doing it?
Because you just can't do it. So
we want to be able to estimate to like see what it's close to, right?
Yeah.
Okay, well, are you up for this big one right here? Can you do the whole thing? Let's do it. You're already an expert in regrouping. Well done. There you go. Good. So 15 minus 7, right?
Yep. It is
It's coming.
8.
Well done. Yep, you got it. And then we got a 7. Uh-oh. More regrouping just for you.
Yep.
I like how you write the whole new number there. That's a good idea. Got another 8. I got to get in here. I'm going to put the comma in there.
Okay.
All right. How about 2 minus 8?
Nope.
Nope. More regrouping. Seems to be your favorite thing today.
Apparently.
All right.
Really, but
now you got 12. Good.
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 And then the 2.
Good. Nice job. Now let's compare these two numbers. Look at them real quick. Can you tell me what this number is right here?
250,000.
Good. How about this number over here?
204,878.
And if this one at the end of your problem ended up being 749,000, what would that tell you?
My estimate is wrong.
Oh, your estimate's wrong? Or maybe even you made a mistake over here, right? Something's wrong, and it gives you a hint. Maybe I should go back and take a look at what's going on. But these ones, they're both in the 200,000s, okay? Not super close, but they're close enough for us to know that they're probably pretty good. Well done. Nice job. I like that problem.
All right, good work right there, Riley. We'll give you a break right now. Hey, you know what? On Wednesdays, we go out to local businesses to find out exactly how they apply math in what they do. Right now, we're going to go visit Devin at the ROC with our friends from Kern Schools Federal Credit Union.
Hey, thanks a lot, Mike and Scott. It's great to be back here. I hope you guys had a great summer. We're back live out in the field for Do the Math. And today we're here at the Kern High School District's Regional Occupation Center, the Rock. I hope they call it the Rock because it would be a terrible tragedy if they had something like that and didn't utilize it. So we're going to be here all day today exploring what exactly goes on here. Right now, we're right in the main foyer, the main entrance, with Brian Miller. And Brian Miller is the Career Technical Education Supervisor. Brian, thanks for joining us on the show. Great title.
Thank you, Devin. Yeah, thanks for being here at the Rock. So
I've got a daughter. She's 6 years old. Every now and then somebody's going to ask her, what do you want to be when you grow up? And she hates the question because she only knows like 9 things that she could possibly do. Here at the Regional Occupation Center, kids that enter in here, they at least have an opportunity to look at a lot of different opportunities they could have for careers.
yeah, currently we have 27 different career training programs here, which is a great opportunity. It's open to juniors and seniors in the Kern High School District. They come here for a year-long program for 3 hours a day where they get some top-notch training, and it's just a great opportunity for them to explore an area that they're interested in.
Regardless of whether or not they're areas of interest, it's opportunities to really see how the world operates beyond what's familiar to them. Not only an opportunity to find out what they may want to pursue, but sometimes it's just as valuable to figure out what paths you may want to avoid as well. Try something out and maybe it's not working out.
Yeah, exactly. We let all the students know that at the beginning of the year because many of them are here because they know that's what they want to do. But a lot of students will get in there and, you know, part of the program is an internship or that community classroom piece and a lot of hands-on opportunities. And a lot of them will figure out that's not what I want to do, which is just as valuable of an experience for them.
Now, here on the main entrance, you've got some displays that kind of highlight some of the programs. I wonder if you'd take a walk with me and we'll kind of take a look at some of these. Well, I mean, this is great for the guys behind the camera here, right up our alley. So video production, I mean, a big push for this in media-rich 21st century environment.
Right, and this is actually a brand new program for us that just started this year. So We're super excited to get that off the ground. Students will get, experience in all aspects of the film industry, and also some hands-on experience in there as well. So we've got a lot of a wide variety of programs. Pretty much every single industry sector is covered here. We've got a lot of the tech-related ones, like our mobile app development education program here, MADE, he calls it. We've got a video game design program, a Cisco networking program, just some of the tech-related ones. We've also got a wide variety of healthcare programs, 5 different ones from medical assisting, nursing assistant, dental assistant, among some other ones as well.
Especially with things like entrepreneurship and mobile apps, these are the kinds of things where, you don't need to wait for somebody to hire you in order to be successful and make a living. This is something that you could start from the ground up no matter how old you are. So, thinking about that component, not just of the creation of the skill itself, but also how to manage yourself as if you were your own business.
Right, exactly. And really those career readiness skills are something that's embedded in every single program here, and that's really where it gives kids a head start on the next step after they leave high school. Actually, most of our students do go on to post-secondary education, and that's something that we strongly encourage, but they start the path here at the ROC and they get those foundational skills and also the guidance that'll get them to that next step.
Perusing a little bit further down as we navigate through here the hallways at the Regional Occupational Center here on Mount Vernon Avenue in Bakersfield, you get the sense as you enter some of these spaces that these aren't necessarily classrooms. These feel like professional settings.
Yeah, and that's really this school is really the feel of it here is that it is like a place of work. We don't have any bells here, which is probably the first thing that students notice when they come to our campus. And students are treated like professionals, and we treat them like they're our employees here. We have high expectations for them, but we find that throughout the year they really rise to the expectations that we set.
And right along with that is making sure that you build a professional environment that seems like its own community. And one of the things we'll take a look at here, of course, is the current schools branch. Tell us a little bit about that relationship.
Yeah, it is really the relationship that we have with current schools is really that model partnership with industry, and our industry partnerships are critical for all of our programs here. The current schools provides tremendous support as far as just giving us guidance with our curriculum, but even more so with the hands-on real-world opportunities that they provide our students. So every single one of the students in our banking program gets an opportunity for an internship, and the majority of those are in a current schools federal credit union branch. But we also have, what you'll see in a minute, our on-campus branch here where students are working and running that branch every single day.
We can go ahead and take a peek as we look in there. Coming up later in the show, we're going to dive a little deeper into the branch, but there's no reason we can't come in and say hello. How's everybody doing today?
Hey, good. How are you?
So this is an actual functioning branch here at the Regional Occupation Center. This is no playhouse. This is where you can come in and actually navigate through the banking system as a member of the financial community. And so a little bit later on in the program, we're going to meet with everybody here at the Current Schools branch here at the Regional Occupation Center, talk a little bit about how the skills that you're learning about actually apply to things like savings or checking accounts, and how the decisions you make based on the calculations that you have handy influence not just what ends up with your accounts, but the work that everybody at the school managed to do. So we'll check back in a little bit later on in the program, but for now, we're going to throw it back to the studio. We understand a lot of people calling in with problems, but that means that there's a lot of people calling in that are going to get some solutions. So Mike, we're going to throw it right back out to you in the studio and be back a little bit later on.
All right, thanks for that, Devin, out there. You can always bring some money back. Just make sure you leave your name with the credit union out there. Right now, we're going to go to the phones. Our first phone caller of the afternoon, Lupe. How are you today? Hello, Lupe. Are you there, Lupe? I think we had Lupe, a 5th grade caller from Williams. Are you there, Lupe? Well, you know what? If we get Lupe back in a moment, we are going to make you get back to work again. Okay. Are you ready?
Let's go, Riley.
Head back to the board. What I'd like to do is give you one of the numbers that you were already working with. All right? 48,617.
So it's 48,000.
617.
617. Good.
Now, after the 7, I'd like you to put a decimal point. Now, you're going to have to make it a little larger.
Well done.
There you go. Now, select a number between 1 and 8.
7.
Go ahead and write it up there. Write another between 1 and 8.
Can it be 8?
It can be.
Sure.
Now, Scott's going to talk to you briefly about the place values after that decimal point, and then you're going to round it
Okay.
to the nearest tenth.
Okay.
Okay,
Ooh,
so
fun.
take it away.
Are you ready?
Yes.
So tell me a little bit about these place values here. What place value is the 6 in?
Hundreds.
Good. And what about the 1?
Tens.
Tens. And then we have over here the 7?
Ones.
Ones. Gotcha. And the way we signify a decimal in math is with the word and. So when you see that word and, that's when you write the decimal.
Okay.
And then after that one, over here, everything on this side over here ends with a THS. And you have to watch out when you say that, because if you say it too fast, you end up spitting on the person next to you. You gotta watch out for that. So over here, the very first place that you'll go to is just like this place you had here, right? The 10.
Okay.
But guess what's on the end?
Decimal point?
THS, right? Right, THS, right at the bottom there. THS. So ready? Don't spit on me. Let's see if you can say it though. Tenths.
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 Seven.
There you go. Gotcha. And the next place over, right? Just like the next place over to the left.
Yeah.
This is tens. This is hundreds, right? This is tenths. This is, see if I can do it quickly, hundred. What goes in the end?
THS.
THS. You got it. So everything over there has a THS on there, right? And all the people from Tehachapi High School are really excited right now because there's a THS over there. So here we go. We have tenths and hundredths. And Mike, we're rounding to the nearest tenth. Is that correct?
Correct.
Gotcha. Okay, so let's identify the one that is in the tenths place. Which digit is in the tenths place?
The 7.
The 7. And which one's going to help you round?
The hundred.
Gotcha. Here's what I like to do in my classroom. We say, you know what, that's the one we're going to round, and you told me that the hundreds is going to help you round it, right? All right, so what do you think? What's going to happen to that 7? Is it going to stay the same or go up?
I think it's gonna go up.
Awesome. What about all these numbers over here?
Something's gonna happen to them.
Something's going to happen to them too?
Yeah.
Well, you know what? Today we are just hanging out with these
Okay.
decimals. So let's keep everything the same.
Okay.
Go ahead and write all this stuff right before the decimal, all the same over there.
Okay.
So 48,000. 617. And what do you write? Get that dot on there. You can do it. There you go. Good. And now you told me what's going to happen to the 7?
The 7's going to go up.
Good. What's it going to go up to? 17? No. What's it going to go up to?
8.
8. Let's make it an 8. And then what happens to the 8?
Goes to a 7.
This one right here?
Yes.
Well, here's the great part about this method. The reason that I like to do this, we identified the tenths place, right? We circled the 8 because it was going to help. And because I circled it, it reminds me that it changes to a 0, just like all those other zeros that you had in your other problem. So after you round, pick that up. There you go, hold on to it for just a second.
yeah.
After you round, everything else after the place that you rounded becomes a 0.
Okay.
And that helps me remind myself, like, what does it come? Oh yeah, it becomes a 0 because I circled it.
Okay.
So there we are, we rounded to the nearest tenth. Nice job.
There you go, good work, and we'll have you work some more decimals later on, but right now we're going to go back to the phones, and I do believe we have Lupe available. Hello, Lupe.
Hello.
You're a student at Williams Elementary, correct?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on today.
3,502 times 741.
So 3,510,
No, 3,502.
502?
Okay.
Yes.
And what are we multiplying that by?
741.
741. Wow. Lupe, that's a good one. Nice and big. You got a good big one there for us. Now, do you want to do it just like I've written it? Can you see it on your TV? Do you want to do it just like I've written it, or should we break it up into pieces?
I'll do it how you write it.
Just like you wrote it? Okay, so if you can tell me, just like I wrote it, what's the first number we're going to multiply everything by?
1.
1, that's it. All right, so 1 times? What am I going to multiply 1 by?
2.
2, you got it. What's next?
0.
0, good job. And then the next one is 1 times 5. What's 1 times 5?
5.
Yep, you got it. Well done. And the last one, 1 times 3?
3.
3, you got it. Now look at that. This number on top is exactly the same as the number we wrote because all we did was multiply times 1. So I like to multiply times 1. It makes your job a little bit easier. All right, in the next line, can you tell me what place value the 4 is in?
The 10th place.
The tens place. That's exactly right. And we have to show that somehow. So we don't have any numbers over here in the ones place. I'm going to go ahead and cross that out for you because we don't have that yet. We have numbers in the tens place, right? That's the 4. So what should we multiply the 4 by?
2.
2. All right. What's 4 times 2?
8.
8. All right. 4 times 0?
0.
Nice job. Next, 4 times 5?
20.
20. Can I write the whole 20 here like this?
No.
No, not so much. Huh? There's no room. There's only one spot there for it. So this 2, it's got to go somewhere else. That didn't work out very well. Good thing I'm working with a pencil like you do in math class, right? Where does that 2 go?
That 2 goes over the 5.
Yeah, you got it. Oh, wait, you know what? We just multiplied times 5, so I'm going to go ahead and put your 2 way over here by the 3. How about that, okay?
Okay.
So, 4 times 5, right? We had that 20. We put the 0 down and carried the 2. And now we have one last number to multiply times 4. So 4 times 3 is what?
12.
12. Lupe, you're doing a wonderful job. Now, what about that 2? It's kind of hanging out up there. What do we do with the 2 and the 12?
12 plus 2.
Yep, you got it. And I'm going to go ahead and write that right over here. It's 14, right? Nice job. Okay, so we have one more to multiply by. And the last one we have to multiply by is at 7, right?
Yes.
Good. So what place value is the 7 in?
The 100th place.
You got it. It's exactly right. So we don't have anything in the ones place. We don't have anything in the tens place. We have to go right to the hundreds place. And here we go. Are you ready? What's 7 times 2?
Yes. 14.
14. Gotcha. You want to put a 14 in here?
No.
Oh, okay. I'm sorry. So we're going to go ahead and get rid of the 1. We put the 4 down. We're going to carry that 1 like we did last time right over top of the 0. So what's 7 times 0?
0.
0. And then what about that 1? What do we do with that?
Plus 1.
That's it. You got it. And 0 plus 1? We actually ended up bringing that 1 down. That was interesting. Next, 7 times 5.
35.
35. Well done. And I'm going to go ahead and beat you to it because I knew you were going to tell me. The 5 goes down. We're going to carry the 3. I don't want to get confused with this 2 here. So we'll put a 3 right there. Okay. And the last one, 7 times 3?
21.
21. And then plus 3 more?
24.
24. Good job. I got to squeeze it way over here. Hopefully you have more room on your paper than I do. Now we have all these numbers, and what's the very last step, Lupe?
To add all the numbers.
You got it, man. Well done. I like it. Here we go. So 2 plus 0 plus 0. What do you got at the bottom?
2.
2. That's right. I'm going to go ahead and change colors on you here. Watch this for our answer. What about the next one? 0 plus 8 plus 0.
8.
8. Good job. Next, 5 plus 4?
9.
9. 3 plus 1?
4.
4. Oh, you're doing a wonderful job. 4 plus 5?
9.
Yep, you got it. 1 plus 4?
5.
5. And then we have the 2. It's way over there. I still have to squish it in. Now, the last thing I need you to do is to tell me, Lupe, where do the commas go in this problem? Because we have so many numbers, we're going to get all confused saying this number unless we put the commas in the right place. You want to put a comma between the 8 and the 2, 9 and the 8? You tell me where to put them.
Put the comma between the 2 and the 5.
Oh, I like that. Right over here? And what else? Any other commas?
Yes.
Where do you want to put that other one?
Between the 6 and the 9.
Ah, yeah, it looks like a 6, but I have bad handwriting. It's actually a 4. So I'm going to go ahead and put it right there for you. Well done. Now here's your last and final thing. Can you tell me what this number is in words? Can you say that number, the final answer?
2,596,982.
You got it. And then again, I have to remind you, this is a 4, because like I said, bad handwriting. This is a 4 right here. So 594,000. Great job, Lupe. I'm impressed. Well done.
There you go, Lupe. Nicely done. And because that was such a wonderful problem, we're going to send you to the Kern County Fair. So hopefully you have an opportunity to attend the fair and have a good time out there. Have you been to the fair?
Yes.
What's the best thing about the fair? Why do you like
rides.
You like the rides? What ride do you like best?
I don't know. There's a lot of good ones.
Is there one that you always go on or one you go on first to make sure you get to it?
No.
No? You know what? Have you ever done the one where I think it's the Ferris wheel, but the car is turning while the whole wheel is
No.
still? Well,
Too
try
much
that out
turning.
sometime. After you eat, it's fun. All right. Hey, you know what? We'll be back with more right after this. Today we're at Elk Hill School, and today we're here to We're once again at Elk Hill School, and with me is Jordan. How are you today?
Good.
Good. What do we have up here?
Fractions.
Fractions. Can you go ahead and read them for me?
2, 5.
2 over 5, 2 fifths, right?
3 sevenths, 1 thirds, and 2 fourths.
Good. Do you have any idea what we're going to do with these?
No idea.
What do you think we could do with them?
Subtract them.
Well, we could subtract some, but we'll do something even easier. We'll just put them in order, all right, from least to greatest, all right? So we're going to go with the smallest fraction and end with the largest one, all right? How do you think we should go about this if we want to put them in order?
Do by the bottom ones.
Okay, so we have a 5, a 7, a 3, and a 4. So looking at that, you would think that 1/3 might go first? All right, so why don't you go ahead and write 1/3. Then what?
2 fourths.
Okay, so here what we'll do is we'll just put a comma there and go ahead and write 2 fourths next. Then what?
2 fifths.
Okay. And finally,
3 sevenths.
3 sevenths. You know what? Looking at it, it looks like you got a pretty good start on this because it may turn out where this is actually the correct way, but we'll have to take a look at it and see, all right? So let's think about it first of all right? 1/3, okay? Do you know what that would be in a decimal form? It would be about 0.3. 333, right? Keep on going. 1/3, right? 33 and a third out of 100, okay? 2 out of 4. What would that be? If you have 2 out of 4, you have like a half, right? And how would we do a half? Do you know how to put a half? So it would be 0.5. Like if you had 50 cents, half of a dollar, okay? 2 out of 5. Do you think 2 is at least half of 5?
Yeah.
Okay, because 2.5 would be, right? Okay, so that's going to be less than a half, okay? If we wanted to turn this in, because these we're doing out of fractions, right? And we're turning them into decimals. If we wanted to take the 5 and turn it into a 10, what would we have to do to the 5? 5 times what would be 10?
Times.
Right, 5 times 2,
2.
right? So if we go 5 times 2 to get 10, we're going to go 2 times that. So it's 2 times that. So 2 times 2, and you get 4. Exactly, right? So go ahead and put a 4 up there. So 4 out of 10 is the same as 0.40. Perfect, okay? So then we have 3 out of 7. 3 out of 7, because 3.5 would be half. But that's not even half, is it? It's less than that, okay? So taking a look at these, first of all, which one of these decimals is the smallest?
This one?
This one, right? Because 0.3, right? Because you basically have 0.3, 0.5, and 0.4. So 0.3. So that is the first one. All right, so this, out of these 3, forgetting about that one, this one is still going to be first, isn't it? All right, so let's go ahead and write down 1/3 again right there. Now, out of these 2, 0.5 and 0.4, which is smaller? All right, so it's not going to be this one again, is it? It's going to be that one. So put 2 fifths next. All right, then what?
Then
Which was
2 fourths.
2 fourths. And then what's last?
3 7.
3 7s. But we didn't check that yet to see if it was correct. So put 3 7s first, right? And now we'll check it because we know that these three are in correct order, okay? So all we have to do is see if this is bigger or smaller than that, okay? So we have a 4 and a 7. So what we're gonna do is when we compare fractions, we'll make the same denominator, all right? We're gonna make them out of 28, okay? So 4 times 7 is 28. So we're going to go 7 times that. So you know what 7 times 2 is, or 2 times 7?
14.
There you go. So put a 14 up there. And this one, to go from 7 to 28, we multiply by 4.
4.
So now we're going to go 4 times 3.
12.
There you go. So put a 12 up there. So out of these two, 14 and 12, which is larger?
14.
The 14 is, which is this one, right? So let's go ahead and write these first two down again, because we know those are in correct order. Good. Now out of these two, which one is actually smaller? That one, which was 3 7s, right? And what is the final one now?
2 fourths.
2 fourths. See, and what we can do is we can look at this now and go, all right, the numbers didn't go exactly in order as far as the bottom ones, like you were saying at the beginning, but we were pretty close. But 1/3's not even a half. 2/5, not even a half. 3 7s, not even a half, but we know 2 fourths is a half. So we know that by looking at it, that is going to be the largest one, and we just proved it. Jordan, nice work. And once again, a special thanks to all of the staff and students at Elk Hill School. We had a wonderful time going out there to visit with everybody. Hey, if you'd like Do the Math to come out to your school, simply give us a call. The phone numbers are at the bottom of your screen periodically throughout the program. Just speak to one of the phone tutors. They'll get us the information, and we'll see if we can make something work out there together. We also are going to head back out right now with Devin and our friends from Kern Schools Federal Credit Union. They're at the ROC.
Thanks a lot. We're back here at the Kern Schools Federal Credit Union branch at the Regional Education Center. We've been exploring the facility here and learning a little bit about how a lot of what the kids do in this facility really mirrors what they'll do in the real world. Joined right now by Kiana Nelson. Kiana, thank you for joining us on the show today.
Thank you for having me.
So, this is a fully functional branch, very similar to what students at any of the other Kern Schools branches. Tell us a little bit about some of the similarities and differences.
Major difference here at Kern Schools is that it's the student branch that is completely run by our high school students. They can be a junior, senior to be in this program. They do mostly all the same actions that we do at a fully functional branch, but since we're on a smaller level, they'll just do deposits, withdrawals, payments, but we give them the same great service that we would at a bigger branch.
So maybe they're not taking out home loans or anything like that, but a lot of the interactions that you would normally do within an actual branch are there for the students.
Correct, yes. The students can do all of our transactions that you would do at most of our big branches, deposits, withdrawals, transfer payments, things like that.
In order for students to be a part of the program here, are there any requirements as far as participation, classes, anything like that?
Yes, here at ROC they do, they are part of what is called the Banking and Finance program, so they are part of that program, and then they can get an internship here in the credit union. So we do hire juniors and seniors as high school students to work in here, but they interview, and then that's how we base our decision on who we pick.
That's a big part of it too. The interview process is something that if you're not familiar with when you do start applying for programs and positions can be very intimidating. So having that experience of being able to sit down and really explain your benefits and selling yourself as somebody who can contribute in a professional environment, it's really valuable. I mean, you're never too young for that.
Exactly. That's what we want to start off teaching, that interview skills starting from the beginning so they are ready for the work field.
We wanted to take an opportunity and really explore the kind of math that takes place here, and it may be familiar to a lot of you at home as well. So let's go ahead and take a look behind the door here. I would not recommend going behind the door of any bank branch without explicit permission. A lot of alarms tend to go off, and banks tend to get very nervous when you get near things like vaults or safes without being asked first. But we got special permission today. I hope we have special permission today.
You do.
Okay, thank you very much. So join here with Angelica and Paola to talk a little bit about the kind of math that you might start to interact with either behind the counter here or on the other side. So we were talking a little bit about things like savings and something very significant in types of accounts, interest rates. Could you go ahead and just kind of tell us a little bit about what an interest rate is?
Yeah, so basically it's a percentage of the loan that a member is being charged. So let's say that you want to take out a loan for a car or something that you want to purchase for $1,000 and the interest rate is 10%. So 10% of your loan is what the member is going to be charged for.
So in addition to the $1,000 that you'd have to pay back, you're basically paying back a fee to the bank for the right to borrow that money that you would pay progressively over that term. So, it may not sound like a big deal, but if you have, let's say, a $1,000 loan at 8% or a $1,000 loan at 10%, how could we figure out what the difference between those two would be?
I mean, we can go ahead and do the math on here.
That's what we do here. Wonderful.
All right. So let's say, you're taking out a loan for $1,000, and like we said, the interest rate is going to be 10%. So we're going to multiply that by 0.10, and then we have all zeros here, so we're going to zero that all out, and then we're going to bring down a zero here. Again, now we have the 3 zeros right up here, and then 1 times 1 is 1. And then we're going to move our decimal over here. So for 1 year of borrowing a loan of $1,000, you're going to be paying $100 in interest.
What's really interesting about the way that you multiplied that is that when you talked about 10%, is that you actually wrote that out as a decimal point of the 1 0. And sometimes people will write that value as just a 0.1, but when you put that in with the standard multiplication algorithm, it comes out to the same thing. And I know sometimes that decimal really throws people off. What I generally do is I'll write that as a percent, we mean out of 100. And when you multiply the decimal representation of the percentage as a fraction, actually it's easier to multiply. So you have 1,000 times 10, which is 10 thousandths, times 1 and 100. And so you can get rid of those zeros as well, and you'll still get 100 divided by 1, or $100. So a 10% interest rate means you're going to be paying $100 extra to the bank. And you can pretty much calculate, if you tried to do that with an 8% loan, that would end up being $80 back to the bank. So the difference there is $20 over the term of that loan.
Yeah, so you definitely want to go somewhere where you have an interest rate that is lower. That way you save yourself some money in the long run.
It doesn't sound like a big deal, 2%. But the bigger the loan, the longer the term, it has a big impact. Paola, thank you so much for working that through with us. We're going to come back a little bit later on and go a little bit more in depth about where this takes students that take part in this program. But for now, back to the studio. Mike, take it away.
All right, thanks for that, Devin. Hey, do remember we have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Right now, we're going to go back to the phones. Another student from Williams, and this is Hannah. Hello, Hannah. How are you?
Good.
As soon as you're ready, let's hear the math problem that you're working on.
Okay. It was a moving company hired 578 clay pots to a florist shop, and the florist will pay the moving company $200 fee. And I found the answer for it. It was 4 plus 2 equals 6, and the number of pots delivered safely were 572.
Gotcha. Okay, so we have 578 pots, right? And tell me a little bit about this fee. We have a $200 fee, right? They're just going to pay them a flat $200, or they're going to pay them per pot?
Excuse me? What?
Are they going to pay the moving company per pot that they move, or just flat $200?
$100 for each pot that is delivered safely.
Whoa, that's a lot of money for pots. All right, are you sure it's 100? Check that decimal place. 100 or $1 per pot?
$1 per pot.
Oh, gotcha. Okay, so they're going to pay $200 no matter what, and then $1 per pot that makes it safely. So out of these 578, I heard you say something about, I don't know, some pots got lost or broken or something like that. How many of them actually made it to where they needed to go?
Yeah. If 2 of the pots are lost.
Oh, okay. So if 2 of them are lost, what do you want to do with that 2?
You want to add it because because 4 plus 2 equals 6.
Gotcha. Well, think about this one. Ready? I got 5 right here, right? If I lose 2, oh, they're gone. What do I got left?
3.
Right. So what did I do? I subtracted, right? So let's go ahead and do that on this one. We have 2 pots that are lost that you tell me about there. So how many pots, Hannah, can you tell me that actually made it to where they were supposed to go? What's 8 minus 2?
572.
Almost. 8 minus 2?
576.
Good job. Okay, so 576. And you said it was $1 a pot. That makes it really easy because we can just go like this. $, $576, right? And then you also told me at the beginning that there was a $200 fee from the beginning, so we can't get out of that. So we better add that to this as well. Can you help me do some addition here, please? What's 6 plus 0? Hannah, you with me there? What's 6 plus 0?
6 plus 0 is 6.
Good. What about 7 plus 0?
0.
7 plus 0? You got it. It's a 7. I'm going to ask you a trick question here. What's 5 plus 2? Ready? You can do it. 5 plus 2.
7.
There you go. So we got 2 7s and a 6 at the end. And so this is how much money we're going to pay to get those pots moved. Now there's one last part of this problem that you told me about, and it said, what happens if the pots get broken?
If the pots get broken, they have to pay the company $24.
Oh, they got to pay some money, right? So they got to pay them back. They're not going to pay for that.
Yeah.
So far we have this amount, right? Can you tell me how many pots got broken?
4.
4 pots got broken. And how much do they have to charge for each pot that breaks?
$4.
Good job. So we got $4 here. So what do you want to do? Add, subtract, multiply, or divide? We got 4 pots, and each of them is $4. We can even do this, right? Out of these 4, we can see 4 of them. We got $4 and $4 and 4 and 4. So all together, how much are we not going to pay for? Can you add all those together? 4 plus 4 plus 4 plus 4?
16.
You got it. Well done. And so if you look back over here, what do you think I was looking for here? We have 4 and 4. What do you think would be a little bit faster than adding them up? Multiply, divide, add, subtract. What do you think? I'm going to give you a little hint here. Ready? There's your 16 bucks. So the deal is, right, you can't pay for pots that are broken. Nobody wants broken pots when you get there. So at the very, very end, we were supposed to pay $776, right? But we can't pay for the pots. So now what do you want to do with these two numbers? We got 776 and we got 16, right? We are not going to pay for them. So what does that mean? Add, subtract, multiply, or divide?
We want to subtract how many pots were.
Great idea. Let's do that. I'll put a $ sign down here so we don't forget. What's 6 minus 6?
6 minus 6.
What's 6 minus 6? You can do it.
A 0.
There you go. We're going to go in green now because we're talking about money. 7 minus 1?
7 minus 1 is 6.
Good. And then we don't have anything left for this 7. So at the very end of the problem, if you can see on your screen, how much are you going to pay this moving company to move all those pots?
760.
Nice job. Well done. I like it.
Nicely done, Hannah. Congratulations on that. And you're also going to the Kern County Fair, courtesy of our friends out there, so we hope you have an enjoyable time out there if you're able to make it. Hey, we do have phone tutors available until 5:30, and we had somebody email a question, and we got back to them, but we're going to put it on air right now, but we're going to make you do it.
Okay.
Okay, sound good?
Oh, Riley's ready.
It has some decimals in it, and you've gotten used to decimals a little bit today. So we're going to work with this, all right? So we'll wait for Scott to get the board erased.
Nope, not going to do it that way. You want to grab your pen? We'll see if we can get this area all cleaned off here for you. You want to start erasing? It's not doing it for me today. Okay.
Here, you know what? You have your...
You want to go back on that one?
Yeah, hold on there. Let me...
All right.
There we go.
Hey, look at that.
All right,
back
here we
at
go.
Here we go.
Indeed, hooray. All right, so you've got 3 minutes to solve this problem.
We can do it.
All right?
Okay.
Carl is building a table. The boards are 4.25 inches wide.
Okay.
Here we go.
So every board is 4.25 inches. The table needs to be at least 36 inches. How many boards will she need?
Gotcha. Any kind
And
of
you
estimate?
have
Round 8.
a little over 2 minutes right
We can
now.
do this. We can do this. What do you think about an estimate? What do you think it might be close to? And we'll kind of try that.
8.
8? How come 8? Well, let's see. Let's see where we're going to end up. What's 4 times 8?
4 times 8
Yeah.
is 32.
Gotcha. Okay, so if we were going to multiply this number times 8, right? Then we would get approximately, maybe not quite, but about 32. So that's pretty darn close. Gotcha. What do you think? Do you think we can actually multiply this out and see what the real answer is?
Maybe.
Maybe. All right. So at least we're pretty close, and if we're not quite high enough, now it says that we want to be at least, right? At least 36.
Yeah.
So if we're not over 36, then we're going to be in trouble. We can go one more, but we'll see kind of how this goes. All right, where do you want to put that 8?
The 8. Let's see. Under the 4?
Underneath it. Let's go ahead and do that. Why don't you put it underneath the 5, and then we can be able to multiply. There you go. And a big line. Nice. Now don't worry about the decimal for right now. We'll just go ahead and multiply that out.
Okay.
Go ahead. You want to multiply it?
Sure. 8 times 5 is 40.
40. Good job. And the 4 goes way up. Well done. I like how you put the plus sign in there. Reminds you.
8 times 2 is 16.
Good. I'm glad you're talking it out.
4.
And then we got 4 more. And that gives you a 20. Good job.
And
And 8 times 4?
4 is 32.
Plus 2 more?
is 34.
34. Gotcha. Now, how many decimal places did you have in this problem here?
1.
Tell me about 4.25. How many decimal places does that number have? Remember we talked about the first place is what?
Is 2, 5.
The tenths. Remember the tenths place? And the next one is?
The hundredths.
The hundredths. So we have 1, 2 decimal places. So what that means is we need 2 decimal places here in the answer.
Okay.
Can you go over 2 places and put your decimal in there?
Maybe right here.
Yep, right there.
Right here?
Yep, right there. You got it. That decimal really will show up. So the answer right here, as far as we have, right, is 34.
And I'll
Now
give
we're
you
back
30
to the question.
seconds to finalize this
We're
problem.
back to the question.
Okay.
Is that enough? Is it 36?
Bow.
It's not. It's about, but not quite, right?
Right.
So if we want, do we want to get bigger or smaller to get to 36?
Bigger.
Bigger. So let's make this 8 go up 1.
9.
9. There you go.
Okay.
So your estimate was a good one. We tested it out. It didn't quite work. But we're going to have at least 9 to get to 36, right? Nice job. 9 boards. Well done. I like it.
There
I'm
you go,
impressed.
because that will put you over the 36, because it'll say 34 plus the 4 is 38. The extra is extra.
Extra is extra.
Nice work right there. Hey, you know what? Final time this afternoon, we'll go back out to Devon at the ROC with our friends from Kern Schools Federal Credit Union.
Hey, thanks a lot, Mike. Back here at the Kern Schools Federal Credit Union branch at the Regional Occupational Center on Mount Vernon Avenue. Wrapping things up here on a Wednesday afternoon with Angelica Alvarado. Angelica, thanks for joining us this afternoon.
Thank you for having me.
So I want to turn back the clock a little bit.
Okay.
The year's 2004. What's going on in this location and with you here in Bakersfield?
2004, I am a senior in high school, and I am the first class opening this branch. So my year was the first year that this branch here, specific branch ROC, was opened. I was a student. I was nervous, I was scared, but I was excited, and I am here now as an employee.
So what was that transition like? I mean, what was it from here to the full position with Kern Schools?
It was, I mean, this gave me all the experience that I needed to be where I am now. I learned everything, you know, to everything from a handshake to eye contact, professional dress, professionalism, confidentiality, just different things like that that at home, because my parents were always at work, I didn't necessarily learn it from them, but this gave me all of that experience, so it was very helpful and very beneficial, I feel.
In terms of coming into the organization, it's helpful because a lot of the same systems that you use here are the exact same things, like the computers, the rules, the procedures that they use at the full branches.
Right.
Yeah, everything that we have here is exactly it's live. We're a live branch, and so everything that our students learn here is everything that they do at one of our regular branches. And so we teach them everything that they need to learn, and so a lot of them start applying for jobs at towards the end of the school year, about May. And if they are hired, then they are ready to go. We don't have to retrain them because they've already had the full school year worth of experience and training. So. It's pretty seamless.
So if somebody is in the high schools right now and they're looking to get involved with the program, what are your recommendations, or what is the process for that?
If anybody is here locally in Bakersfield, all they need to do is be a sophomore in high school or a junior. You can come see your counselors, and they have all of the information. So all they need to do is be enrolled to Regional Occupational Center, and then the banking and finance class is the class that's attached to this particular internship. And so once they're enrolled in the banking and finance classroom, then they will have the opportunity to then apply and interview here with Kern Schools. And then we start training them right before school starts.
Well, Angelica, I wanted to thank you and everybody here at the Regional Occupational Center for their hospitality and bringing us in today and letting us look around, bringing us behind the counter. I know that is a wonderful blessing that you've given us the opportunity to do so, because I know that this is sacred, hallowed ground in the financial community. And to thank you for your continued support with the Do the Math program, as we do with anybody who makes a significant contribution specifically with our show. We wanted to offer you, as a token of our appreciation, our Do the Math tile, as is tradition with the program.
Thank you.
Got that frame really nice here. Check in through us throughout the season as we visit more and more businesses in the Bakersfield area, as well as anywhere where math is happening, to see how this applies. What you have going on, besides the things that you're picking up, you use them today and you use them for life, as we've been able to see. Yes. So, Angelica, thank you so much, and everybody here at Kern Schools Federal Credit Union at the Regional Occupation Center. We're going to send it right back out to the studio. Mike, Scott, take it away.
All right, thanks for that. We've got Riley in here, and she thought she was finished working today, but you still have a little bit to do. We do have phone tutors available until 5:30 this afternoon, and you want to go work on the phones and answer questions for a little while?
Sure.
Hey, there you go. That's what I like to hear. Phone numbers are at the bottom of your screen. Do remember, every time next week, next Tuesday and Wednesday, we do one of your math problems, you will also win yourself a free ticket to the Kern County Fair. But the students that phoned in today are also entered into a drawing to go see the Bakersfield Condor. So reach in there and pull out one of those names, and we'll find out who's going to see the Condors. Who is that?
Hannah.
Hannah. So there you go. Congratulations. I believe that was our last phone caller right there. So you're going to see the Condors, and since you're going to work on the phones a little bit, you did some work today. We're going to let everybody see your new uniform right there. Do the Math shirt. And your mom already said that you could wear that every day for the rest of the year, except for campaign week, right?
Yeah.
All right. There you go. Nice deal.
Not every day. It has to get washed sometimes.
Do that on Saturday and Sunday. All right. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California. Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott. And if you'd like to call us up and ask us one of your math problems, give us a call here in Bakersfield, 636-4357. If you're in San Luis Obispo, toll free, 866-636-6284. You can even email us your question at dothemath@kern.org. You can watch the show online if you're not already watching on your cable broadcast at dothemathonline.net and all over social media. You can get a hold of us by Facebook, Instagram, Twitter, and YouTube. Give us a call.
All right. Now, you said that they can call with one of their math problems.
Right.
What if it's a really long and detailed and difficult math problem?
Then maybe we can get them their own show. How about
There
that?
we go. You know what? But we'll still help them out. And if you have another problem, we can always work with that one also.
Right.
But you need to give us a call first. That's the first thing you need to do. Today, big day.
Yep.
Opening day of the fair.
That's right. I've already been there, actually.
You have?
I was there early.
It's opening day.
That's right, because my kids have pigs going in the fair. So I went to
Oh,
see
right.
where we're going. The animals are starting to show up. The people are starting to show up. It already smells like corn dogs. It's a good place to be this time of year. And it's not 105 degrees.
It's funny because yesterday in the cafeteria they were serving corn dogs.
Ah,
It's like, getting ready for the fair,
yeah,
huh?
that's right. They can hear it coming.
Anyway, today is the first day of the fair, and like last week, today also we will be giving away tickets to the Kern County Fair to all of the students that are able to go on air today. So if you give us a call and we do one of the math problems on air, you will be going to the Kern County Fair for free. If you're phoning in from San Luis Obispo County and for whatever reason you're coming over to Kern County, you want to go to the fair, let us know. We'll give you a ticket to the fair. But if you're staying in San Luis Obispo County, we can give you some free ice cream courtesy of Doc Bernstein's Ice Cream Lab.
Pretty good deal. Maybe we'll go to San Luis
Now-
Obispo at some point and get some
Oh,
of
you
that.
know what? I'll bring you over sometime because we go over there every year and we film over there and we stop by Doc's and see him every year. Do you have a favorite flavor?
Mint chocolate chip, definitely my favorite ice cream.
All right, you know what? They have that over there,
Big
and I'm
fan.
sure they can make something up for you too.
All right.
Also, hey, you know what? Guest in studio, and we have some phone calls to get to. But first, let's take a look at today's Math in the News. So this morning, somebody said, "Hey, did you hear about the nails?" And I'm
nails.
thinking nails like a hammer and nails.
Right.
Right, like some new nail come out or something.
Sure.
So when you think of nails, do you think of that or do you think of
I definitely think of the
fingernails?
hardware part. Like all the prices went up because of the hurricanes and they're fixing a bunch of stuff. And anyway, we went way down that track. But we're looking at some different nails.
Could be, yeah. So let's go ahead and take a look at the... And we can see that there are a bunch of different types of nails on there. So, and I am sure there is a lot of money in nail art.
Right.
Okay. So we can see where there's some, you know, I guess you would say kind of ordinary or plain, you know, just like two colors on there. Festive,
Yeah.
you know, and then some where I would imagine it's going to cost a little more based on the type of nail polish and things like that that you're doing. So the reason I bring this up, and we can go ahead and take a look at the photo we have under the camera. This is Miss Williams. And Miss Williams has taken 20 years to achieve the nails on her hand that she has right there. She lives in Texas.
Yeah.
Big fan of Texas. Everything's
Right.
bigger in Texas. Well,
Everything,
big
that's right.
fingernails
Even
are in
fingernails.
Texas too. And 18 feet, 10.9 inches, the cumulative length of those nails. Now, it takes her, now, she is a nail technician. So she does this stuff.
And she can still work with those nails.
Over 20 hours to paint her nails.
Wow.
Okay, 20 hours to paint her nails. 2 bottles of nail polish. All right, only does it once a month, uses acrylic. I guess that's the superior one if you're going to do it once a month with nails like that. She washes them 3 times a day, just the nails, not your hands, just the nails, and rests them on a pillow. Okay?
Special nail pillow.
I kid you not.
All right, you can't make that stuff up.
I clean them with a brush at the sink, she says. I use disinfectant or bleach, and sometimes if I'm eating popcorn, I would just stab it, right? She uses a spoon and then uses a pencil or one of her knuckles to use her cell phone or computer. And get this, this is the best thing about this. She doesn't have to do any chores around the house because she can't do anything.
Right.
Right? So what she does is she has somebody else do the chores around the house.
Man.
So I figured, all right, let's apply some more math to this. So here we are with converting measurements. So we'll take a look at the screen once again. Customary units of length. So we have 1 foot is 12 inches. We all know that. 1 yard has 3 feet. So if we take a look at the 18 feet and 10.9 inches of nails that she has, 227 inches approximately, or 6.3 yards of nails. Simply amazing, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available on Tuesdays and Wednesdays between 3:30 and 5:30. And in studio with us right now, we have a young lady from Stockdale. And why don't you let everybody know your name and what grade you're in?
I'm Rhea Kelsey, and I'm in 4th grade.
All right. And Rhea, do you have nails anywhere near that long?
No.
Let's see.
No. No, see, I mean, all our nails, I mean, are pretty, like, I would say, normal length, right? Do you think you would ever want to do anything like that?
No.
Do you have any idea why she did that?
No.
To get into the Guinness Book of World Records, and she got in, which is why the story is out there. So she is now in the 2018 Guinness Book of World Records for having almost 19 feet at present of cumulative nail length.
Yeah.
That is simply amazing. But anyway, how's 4th grade?
Good.
Do you like going to school for a longer day now?
Yeah.
You like that?
Mm-hmm.
Guess what's going to happen when you go to 7th grade? You're going to go to school even longer. Are you good for that?
Yeah.
What about when you go to high school and you have to go to school even longer than that? Are you good with that?
Yeah.
All right. And what about after that when you go to college or work and you have to go even longer than that? Are you good with that?
Yeah.
All right. So you're good with basically anything that goes on, right?
Mm-hmm.
All right. Well, how about we do this? How about we put you to work?
Okay.
Are you ready? All right. Head on over to the board with Scott. We are going to take a look at your book, and we're going to do one of these problems, and we're going to do number 2. So what I'd like you to do is maybe at the very top of the board, write down these numbers. All right? We have 5, 3, yep.
There you go.
4, 9, 8, and 1. Now on here, the book says, Nancy wrote the greatest number that can be made using each of these exactly once. So why don't we do that first? So what is the largest number you can write using each of those once? And while you're doing it, explain to us what you're doing and why you're putting numbers in a certain place.
Okay. I put 9 here because it's the greatest number.
Good idea.
And then I do an 8 because it's the second biggest one.
Yeah.
Then I do a 5. And then a 4. Then a 3. Then a 1.
Awesome. Okay. You think we could put a comma in there so we could figure out what this number is? Where's that comma go?
Right here.
There you go. Do you know what that number is? Can you tell us what it is in words?
885,431.
Good job. And the first number's a 9 there, so 985,000. Now, are you sure that's the biggest possible number that we can make with those numbers? Those digits? I like how you went from biggest to smallest. That was a good idea. So if you switch the 1 and the 3 around, that wouldn't be a bigger number?
No.
No, it wouldn't. You're right. I like that one. What else you got for us, Mike? What
All
other
right, you
challenge
know
do we
what?
have?
Let's take a look at one more right here. We've got a couple of options on number 1.
Okay.
So let's take a look at this. And it says, select a number that will make a true comparison. Mark all that apply. So why don't you go ahead and erase that, and there's a way, Scott, there you go, see that?
I'm getting better.
You don't have to do that little erase and get rid of it all at once, all right? The number is 703,209. So 703,000.
I'm going to stick a 0 in there for you. Woo! 703.
209.
Well done.
And Scott, how about if on the left-hand side you make a column of these numbers?
Okay.
All right. The first one, 702,309. The next one, 703,029. The next one, 703,209. The next one, 703,290. We have 2 more.
I got you writing too big there. All right.
That's okay. You can squeeze these in somewhere. 730,029. And you could probably squeeze one between the first and second one, I would imagine.
I think you're right.
730,209. Now,
Right.
we have Ria's number, 703,209. Next to that, we have a greater than symbol. So at the end of the 9, put a greater than symbol.
Aha, so you have a sign there, right? And this sign's going to say that the number over here is bigger, but what Mike wanted is a greater than sign. So is it true, Mike, that we want this number to be bigger than the new one? Is that right?
Correct.
All right, so can you erase that real quick and see if we can go the other direction? There you go. We'll make it go the other way. So, just to make sure we're clear, right? We want to choose some numbers that are smaller than this one so that this one is going to be bigger than the ones we choose. Does that make sense? Okay, so we need to look for some numbers that are smaller. And is it true that the instructions say we want to choose all the numbers that are possible
Yes.
to get smaller?
All
Okay.
that apply.
Gotcha. So what do you think? Should we just look at all of them, or should we go one by one? What do you think?
We should go by one.
Yeah, I think so too. All right, so what about the very first one that we have on the top here? This number is 702,309. Is that bigger than what you have? It's got the same numbers in it, got the same digits.
But it's not bigger.
It's not bigger. How come? What's wrong?
Because right here in the thousands place, there's a 3, and that one, there's a 2.
Yeah, that's right. So I'm going to underline that one for you real quick. So this part was the key to this one, right? And it's smaller, so that one would work, right?
Okay.
That one would work on our spot. So over here, can you make a list of the ones that work? Why don't you go ahead and write that number that we have up here, 702,309. Yeah. 309. That's one of ours. And so we have used that one. What about the next one? Again, we're looking for numbers that are smaller than yours, right? So the next one, I'm sorry that I have kind of bad handwriting here, but that one says 730,000. What do you think? Bigger or smaller than the one you have?
It's bigger.
It's bigger. How'd you know that?
Because right here, there's a 3 in the 10,000s digit.
3 in the 10,000s. That was the giveaway, huh? So that one, not going to happen. Next one. What do we got?
3.
703,000. So we have thousands, same. 10,000, same. So the criteria that you used up here, so far, were the same. What about the next one? The next place is the hundreds place, right? And now I have a 0 and you have
A 2.
a 2. Is your number bigger than this one?
Yes.
It is. It's going to work. So let's go ahead and make that part of your list also. Well done. So we have that one. Nice job. Next one, 703,000. So far we're the same. Then we have 209. Have you ever seen this number before?
Yes.
Where?
Right here.
That's the same number. Exactly. So is your number bigger than this number?
No.
I think I'd have to agree with you. Not going to happen. Doesn't work. They're exactly, what
The
else would you say? That is the same, yeah. So if you had an equal sign there, it would work, but not a greater than sign. Next, 703,000, which is what you have, 290. And last time we looked at the hundreds place, but you have a 2 also. So we got to keep going, right? What's the next place?
The 10s.
Yeah, the tens place. And now I have a 9, and you have a 0. Is yours bigger than mine?
No.
Nope, not going to happen. So this doesn't work either. We got one more option, right? We're dealing, notice every single number we have on here has the same digits, right? 7 and a 2 and a 3 and a 9 and a couple of zeros. They're just all mixed up. So can you tell me what this number is? Say this number out loud. What are the words that go along with it?
730,024.
Yep, that's it. And it's because of my bad handwriting, but it's a 9 there. But you're right, it is 730,000. So is 730,000 going to be smaller than yours?
No.
Not going to happen. So looks like we have 4 strikes, and we have 2 of them that worked. So 2 out of the 6 worked out okay. But I think if we were playing baseball, Mike, we'd be struck out by now. We struck out with 4 of them.
All right, there you go. Well, nicely done. And Rhea, because you're a guest on today's show, you'll be receiving a free meal courtesy of Liddy and our friends over at Johnny Rockets. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. Just as a reminder, today is the final day, September 20th, the first day of the fair. But it's the last day on Do the Math where you can actually win a ticket to the Kern County Fair. And right now we're going to go to the phones. And Riley, how are you?
Good.
And Riley, you are a 4th grade student as well, correct?
Yes.
Okay. So Rhea, usually I have you come over here and you stand by me and we just watch Scott do the problem. But I think the problem that Riley is phoning in with is one of the problems in your book. So I want you to help Scott figure this out and explain it. All right? So Riley, as soon as you're ready, go ahead and read the problem. And Scott, if we need to, I've got it under the camera out of Rhea's book.
Sounds
all right?
good.
Riley, let's hear it.
The total season attendance for a college's team's home games, rounded to the nearest 10,000, was 270,000. For numbers 7A through 7D, select yes or no to tell whether the number could be the exact attendance.
So if you want to, I can give you these numbers and you can write them down.
Sure.
All right, so the first number is 265,888.
Okay.
The next number is 260,987.
Okay.
The next one, 274,499. Final one, 206,636. Now, next to each of those, there is a yes and no.
Okay.
So I guess you can just put a Y and an N over there next to each of those. And we're going to reverse roles. Scott, you're going to stand there. And Rhea, you're going to go through this problem with Riley and figure out how we need to answer this accordingly, all right? So the question says, select yes or no to tell whether the number could be the exact attendance if you were rounding this number, okay?
Now, which place value are we rounding to again?
Now let's see, it says to the nearest 10,000.
Gotcha. So let's look at the first number at the top and just make sure you know what the 10,000s is, and then I promise I'll be quiet and let you do it. Which place is the 10,000s up at the top number there?
This one.
Gotcha. Okay, go ahead and underline that one real quick. Okay, so how would you go about doing this one?
I would go next door. If this is 5 or more, I change this, add one more, and if it's 4 and less, I keep it the same.
That's exactly right. You got it. And so let's be clear about what the question asks, right? It says one of these, or maybe more than one, could be the actual number. And if you rounded it to the nearest 10,000, you would get that answer. Does that make sense?
Yeah.
So we need to look at each one of these. Maybe we could look at them and just think about, if you rounded to the nearest 10,000, what would you get, right? So go ahead and look at the first one. If you rounded the first one to the nearest 10,000, what do you think you'd get?
I would get.
Yeah, that's the 10,000s place. That's true. It's supposed to be an arrow, I know.
And I would write.
You want to write right under here? Well done. So how did you get that? Can you tell me why you did what you did?
Because I looked at the 6. I came over here. This is a 5, and that's more than 4.
Right.
So I add one more to the 10,000s, and I got that.
Nice job. So you can either go up or the same, right? You can never go down. Same or up. All right, so that one worked. What do you think, yes or no? Does it look the same as that one?
Yes.
Yes. Go and circle your yes. Next one. How would this one round to the nearest 10,000?
So hold on, before you get to that next one, Riley, does that make sense to you as well?
Yeah.
All right, so you're going along with all of this. So, Rhea, how about if you ask Riley how to do the next number?
Okay.
All right, so ask Riley whatever you would like to ask her.
Riley, what does the 10,000s round to?
Riley, which number's in the 10,000s place?
I couldn't hear the number.
Oh, the next number
So
we're
we're
looking
on
at
the
is...
second one.
Yeah, the second one that you gave us, 260,987.
So you look into the 100,000s place.
100,000s, okay, we got the 2 over there, right?
Mm-hmm. And then you go next door and see if it's 5 or more. And then if it's 5 or more, you add one more to the 2.
Right. Now let's look back at the question. Remember, Riley, it said that we wanted to look at the, we're going to round to the nearest 10,000, right?
Oh, okay.
That's okay. Which digit is in the 10,000s place?
Oh, the 6.
Good job. So there's a 6, and now you can tell us what to do from here.
So you look at the 6, and then you go next door. If it's 5 or more, you add one more. If it's lower than 5, you keep it the same.
Mm-hmm.
And since it is lower than 5, then you keep it the same. So the answer is 260,000.
260,000. Can you write that right under here, Rhea? 260,000 on that one. So, Riley, did that one work or no?
It does.
Does that work and round to the top number that we have here, 270,000? Does that work?
Oh, no.
Ah, it doesn't work. Okay, go ahead and circle the end. That didn't work. Hey, we're halfway done. Next one, Riley, what do you think? Which digit is in the 10,000s place? 274,000? 7, yep, you got it. And the number next to it is?
4.
4. Does the 4 round the 7 up or the same?
The same.
Same, you got it. So tell Rhea what to write here.
Okay. So you are going to write 270,000.
Yep.
And then you're going to put a yes next to it.
Good job. Well done. And that one's a yes also. Last one we're going to try. Which digit in this last one, 206,636, which digit is in the 10,000s place there?
The 0.
The 0. You got it. Okay. So even if we had a gigantic number next to it, is there any way that you can make that 0 turn into a 7?
Turn into a 7?
Yeah, because at the top it says we have to round to 270,000. Is that 0 ever going to be a 7?
No.
No, probably not going to happen so much. So it doesn't really matter what that other number is. We're going to look at it anyway. But no matter what it is, it's just not going to make a 7. Let's see what this one actually does round to, okay? So Riley, what does the 6 do to the 1, or to the 0? Does it make it go up or does it stay the same?
It makes it go up.
Good job. So tell Rhea what to write here. You have a 2, and then what else?
You have a 2, and then a 1, and then a 0,
Good.
and then a comma, and then a 0, and a 0.
Good. And is that a yes or a no? Does that end up being 270,000?
No.
Not so much. So we're half and half. Great job, ladies. Well done. I like what you did there.
There you go, working together on that problem. It's kind of funny that she called in with a problem that's in Rhea's book so we could actually take a look at it. So nice work, and Riley, congratulations. By phoning in today, you are now going to the Kern County Fair, so congratulations. Hope you have a wonderful day at the fair. 636-4357 is that phone number. We do have phone tutors available until 5:30. Don't forget, if you're calling from outlying areas of Kern County as well as San Luis Obispo County, the number is toll-free at 1-866-636-6284. We'll be back with more right after this. Today we're at Elk Hill School, and today we're here to
Do the math!
Elk Hill School today with Mackenzie, who's in 7th grade. How are you?
I'm good.
All right, come on, turn around here. What's going on up there?
I have no idea.
Excellent. Tell me a little bit about anything you can tell me right now.
Okay, well, I know that these are numbers in parentheses. I think that's a -2, maybe, and that's a +3.
Perfect.
And then that's a plus sign, and this is a 4 with like a squared sign, I think, and then
Perfect.
division, and then 2.
Perfect. Everything is fine so far, so you do know what's going on. Now we just have to figure out how to do it, right?
Okay.
Okay, so this is called the order of operations, okay? There's a specific order that you need to do things. So it's sometimes kids refer to it as, please excuse my dear Aunt Sally, PEMDAS. Okay, if you haven't heard of that yet, you probably will.
I have.
You have heard
like,
of that?
Yeah, like
Okay.
once or twice.
Good. And I'm sure you're going to be doing a lot of that this year and then when you get in 8th grade as well. So we'll go ahead and do one right now, okay, because we've got a little bit of everything in here, okay? So the first thing is parentheses for the P. Do we have any parentheses?
Right here.
Okay, and what's in the parentheses?
A +3 and a -2.
Okay, so if we just read that, it's basically just 3 minus 2.
Oh, okay.
Right? So it's even simpler than what you were kind of thinking it was going to be,
Yeah.
right? So what is 3 minus 2?
1.
So put a 1 underneath it. Now just bring everything else down. Just rewrite the entire problem. Okay, so we did the parentheses. Okay, that's the first thing. We get that out of the way. We know that 3 minus 2 is 1. Everything else is just rewritten. The next thing is the E, exponents. Are there any exponents?
Is this an exponent?
That's the exponent, that's the base. So you were correct in saying that that's a squared. So it's 4 squared. Okay, do you know what 4 squared means? How do you solve that?
No, not really.
Okay. 4 squared can be written as 4 times 4.
Oh, that's 8. No, I mean that's 16.
Right, 4 plus 4. See, that's the reason we put this up here is because a lot of kids will see 4 squared and think it's 8. It's not 4 times 2, it's 4 times 4. Here's an example. If I did 4 to the 3rd power, how would I rewrite that?
4 times 3? No, 4 times...
4. See, that's equal to, so you take the base and you write it that many times.
Oh,
So
so
what's-
it's 4 times 4 times 4.
Perfect, all right? So that's how the exponents are going to be worked.
Oh,
Okay,
okay.
but we have an easy one. 4 times 4 is just 4 squared. So what is that?
That is... I just said it. 16?
There you go. So put a 16 underneath that. Bring everything else down. Okay, so we have PEMDAS, parentheses done. Okay, E exponent done. Multiply and divide are the same at the same time. You just do them from left to right if you have any. So do we have any multiplication or division?
We have division right here.
Okay. And what is that going to become?
8.
Okay, so go ahead and put that down and bring everything else down. So what do we have left?
9.
See how easy that was? Nicely done. Well, we're at Elk Hills Elementary School, and they have a school that goes from kindergarten through 8th grade, correct?
Yes.
And with us right now, Principal Mr. Tenzi. How are you today?
Good. How you doing?
Good. Thanks for having us out.
No problem. Enjoyed it.
How long have you been at Elk Hills?
This is my 7th year. Just started my 7th year here at Elk Hills.
Okay. Kids were fantastic to work with. Great students out
Yeah. We have a great little school out here. I call it my little diamond in the rough out here.
There they go. How many kids do you have out in the
We
school?
got like 175 right now.
Okay. And as we walked into the auditorium here, we saw that you have a theme going on. And what's the theme this year?
The theme this year is it's a zoo theme. It's a welcome to Elk Hills School, and to take a walk on the wild side.
There you go.
So we have a zoo theme going on this year.
And the kids were pretty excited about it the first day of school, right?
Yeah. First day of school, the kids are always very excited to see what the new year is. This is our 9th year, so we're starting to get a lot of good themes going on. But the kids really anticipate the first day of school to see what the year theme's going to be.
So do you have any highlights of themes in past years that you guys have done?
Oh yeah, we've done. We've done Parents, We Shrunk the Kids. We've done 20,000 Leagues Under the Sea. We did Wild Wild West a couple of years ago.
Okay.
So we've had some really good themes.
All right. Well, you know what? Thanks for having us out once
Oh.
again with the Do the Math program. And a lot of avenues you guys probably hit, especially with science and things this year with all of the zoo thing going on.
Definitely.
Jeff, thank you once again.
Thank you very much.
And once again, a big thanks to all of the staff and students at Elk Hill School. We had a wonderful time visiting out there. Kind of cool that they do a different theme every year, and the kids get all excited about it. The first day of school, they bring the entire school into the multi-purpose room. Check that out, and they have a lot of volunteers that help put that together, and that's their theme for the year, and it works. And it's a great success out there.
It's a good deal, yeah.
A couple of other schools do that as well, but I mean, the entire place was decorated with that theme, so it was pretty cool to see.
Great.
You know what? If you had to come up with a theme, let's say you had a classroom or a school and you were in charge of it, all right? Can you think of a theme? Like sometimes they go, we're going to do superheroes, or we're going to do, they did underwater life. Can you think of a theme that you might like to do or see?
Maybe jungle.
Jungle, there you go. That would be a pretty cool one. You know what? Go to your principal and say, hey, listen, I would like the school decorated like it was a jungle, and I want to see some more of that stuff, all right? Don't tell him I pushed you into it. Just bring it up to him and see what he says, all right? Are you ready to do some more work?
Yeah.
All right, head on over to the board. We're going to take a look at it. This is very cool. You have 2 math books. So we're going to go to your other math book now and take a look at what you're going to be working on coming up. So it says that you're going to estimate, and we have 3 problems here. So we'll just do them one at a time. All right, so why don't you go ahead up, right up there, 293 times 4. Now on this problem, Rhea, it says just to estimate it. It doesn't say what place value to estimate it, so it's wide open. So how would you like to go about working on this?
I would like to see what this number estimates to, write it over to the side, and
Good
then
idea.
bring the 4 over
I think
there.
that's a great idea. So how would you round or estimate that top number? What place value would you round it to?
The highest.
Good idea. All right, talk us through it, just like you did the last one, because you're really good at this.
So you go next door. If this is 5 or more, you add 1 more to this number. And it is.
It is.
So you bring it over here, 300
Well done.
times.
Now, what do you think about that 4? Do you want to do anything with it at all? Do you want to round it? Because if you
No.
rounded it down, we'd have nothing. If you rounded it up, might be kind of too big, huh? So we'll just stick with the 4. I think that's a good choice.
Yeah.
What are you going to do now?
Now you multiply it.
Let's do it. Sometimes you wish those things had ink, huh?
Yeah.
You jumped right to it. So I noticed, if we were doing this regular problem, right, we would do 4 times 3 and 4 times 9 and 4 times 2. But you jumped right to the end. Tell us a little bit about how you already knew it was going to be a 1 and a 2 and a couple zeros.
I already knew it was going to be 1 and 2, a couple of zeros, because these two, when you multiply it, it equals 12.
Right, and that's where the 1 and 2 came from. And then got a couple zeros there. You just bring them down or what?
I just brought them down.
You just brought them down, yeah. And if you had to go back and check it out and you were going to multiply, 4 times 0 is 0 and 4 times 0 is 0 also. Nice job, well done. So when you go to the original problem, right, how are you going to look at this answer and compare it to the other one? Is the original problem going to be bigger than 1,200? Is it going to be smaller than 1,200? Do you really care about if it's bigger or smaller?
No.
If this answer that you got on the problem that we're going to do in a minute, if this answer ended up being 17,000, you think that might be a problem?
Yes.
Yeah, too big, huh? So it wouldn't be very close. So we would like it to be close to your estimate.
Yes.
You want to work out the real thing?
Yeah.
All right, let's see what you got. So 4 times 3 is 12, right? You put down the 2. Where's the 1 go?
Up here.
Good call.
And then you do these two.
And your next problem is 4 times 9, right? Okay.
And then that equals 30. And then you add 1 to
Right.
the 32.
Yeah, so 36, right?
Yeah.
And then add
Add
one
one.
more?
And you 37.
37. So what's going to go down on the bottom and what's
This.
going to be carried?
The 7.
Nice job. Yep. Put the 7 there. And then the 3 is going to go way up there. Now, so far, we can't compare it to your rounded answer, right? Because your rounded answer has 2 zeros in it, and this one has a 7 and a 2. So we don't even know if we're close yet, but this is going to be the telltale part right here. Let's see what happens. So your last multiplication is what two numbers are you multiplying?
3 and 2.
Oh, almost. Remember the 3 is going to be added? In fact, I'll go ahead and put a little plus sign here that we're going to add that in at the end. So what numbers are you multiplying?
2 and the 4.
Good job. And what's that?
8.
8, and then you're going to add in your 3?
And that equals 11.
Good job. So put down your 11 there. Good work. So tell us what the actual answer is. Can you say it in words, please?
1,000, 1,172.
Good job. And what's the estimated answer?
1,200.
Are they close?
1,200.
1,200. Are they close?
Yeah.
They're pretty close. How close are they? Let's look at the thousands place. Is the thousands place the same?
Yes.
Yep. How about the hundreds place? Is that the same?
No.
Not quite, but pretty darn close, right? Can you tell us, we don't have to do it if you don't want to, but I'm interested to hear from you, how could you tell how close those two numbers are? Like how far apart they are? How could you do that? What would be a kind of a math problem you could do to figure out how close those two numbers actually are to each other?
Subtract this from that.
That's it. You could totally subtract them and you would see exactly how close they are. Great job. I really like how you worked out that problem. That was awesome. So we move on to the next one. I hear we got some dollar signs over there. Is that right?
Yeah, you know what? We're going to do one more right now. So go ahead and erase that.
Ready? Hooray.
All right. And Rhea, what I'll do is I'll have you move further over towards the center of the board. There you go. Because I've got a little bonus to add on this problem for you later on. All right. So let's go ahead and write down the problem first. $416. So 416 times 6.
Great job. Okay.
And it says to estimate again.
Better do some estimation.
Bring this over.
So you're going to estimate the top number first? Great idea. And which place are you rounding to?
The highest.
The hundreds again, okay.
Okay.
And talk us through this. You have a 4. Is that 1 going to help your 4 go up or stay the same?
Stay the same.
Stay the same. Good deal. And what happens to the 1 and the 6? They become?
A 0.
0. You got it. And then we have the choice at the bottom again. You going to do anything with the 6?
No.
Nah, just leave it. Sounds good. Okay, now one thing when I'm working on a problem like this, so far everything you've done is wonderful, but sometimes you get through all the numbers and at the end of the problem you forget that it had a dollar sign. So here's what I want you to do. Before you even do any numbers at all, can you put a dollar sign here on the real answer and a dollar sign there on the estimated answer so that we don't forget to put the dollar sign and we'll know that this problem involves money? There you go. It's a good reminder. Then you don't have to worry about putting it at the end. Okay, walk us through the estimated problem there. 400 times 6. So you got a 2 and a 4 and a 0 and a 0. And where the heck did they come from?
You got the 2 and a 4 because when you times 4 times 6, it equals the 24, and then you just bring the 2 zeros down.
Well done. I like it. Okay, let's go to the real thing. It's got to be really close to 24,000, right? Is that number over there, 24,000?
Yes.
No. Check it again. What is that number?
2,400.
2,400. So we're hoping that the real answer is close to 2,400. All right, let's see what we got. So 6 times 6?
36.
36. You put down the 6, carrying the 3, if it'll let you write it.
And then you times these two.
Yep, 6 times 1. Nice job.
It's 6, and then add the 3, 9.
9. And nothing to carry on that one, huh? And the last one?
4 times 6.
Yep.
To equal 24.
Okay, let's see how close they are. Are you ready? Is the thousands place the same?
Yes.
It is. Is the hundreds place the same?
It is.
It is. Is the tens place the same?
No.
Not quite. And if you had to figure out how close they were, you told me you could subtract them, right? And the only differences are these numbers right here. So can you, in your head, we're going to put you on the spot here. We'll see if you can do it. In your head, can you tell me how different these are? How far apart are they?
96.
96. I circled it for you. Maybe I gave that one away. So that one worked out pretty well. Nice job. Well done.
All right, over on the far left, Scott, go ahead and write this down. $4.16 times 6. Now, Rhea, go ahead and do that problem. Now that we've put a decimal in there for you and see what happens.
Should we estimate that one as well?
No, we'll just go ahead and do it.
Go ahead and do it. So Rhea, before you start, can you tell me a little bit about this? You did a problem that looked awfully similar over there. This one looks pretty darn close, but you put a decimal in there. What is that going to do to the answer just ahead of time so we know what to expect?
With the decimal point.
You're going to have some decimals in your answer too, right? And also, tell us about your answer. Your answer over there was in dollars. Is your answer over here going to be in dollars?
Yes.
Okay, put that dollar sign in there for us. There you go. Now, do you want to work out all this problem again?
No.
Oh, no, I don't blame you there. Look back over there. Do you see how all the numbers are the same? Everything's the same, right? So the answer to this problem is going to have the same numbers as the answer to that problem, right? Can you write down those numbers? And then we can talk about that decimal place. Yeah, and put the same numbers there too. So 36 carry the 3. 6 times 1 is 6 plus 3 is 9. And then the last part is 6 times 4, right? Good deal. Now, the other one you put a comma in, right? But that's because we didn't have a decimal place. Where does that decimal place go in your answer?
Right.
How'd you get that? How'd you know?
I knew because the decimal point is in the same place as the comma.
Ah, okay. Well, your comma went between the 2 and the 4, and you put your decimal place between the 4 and the 9. So I like that deal. We're going to make this a little bit more of a dot if we can, and I'll do that with red so we know where it is. But look at the very top number. The top number says $4.16, right? How many decimal places are in that number?
1.
You see you have your 1 here, that's right. And then 1 more, right? Would you agree with that? So we have 2 decimal places, right? 2 of them on the right. So this number has 2 decimals on the right-hand side. When you go to do this number, we want to have 2 decimals on the right-hand side. So we're going to go backwards here. And that's why that decimal ended up in the same place. Tell us how much money this is.
$24.96.
Gotcha. And how much money did you have in the problem before?
$2,496.
And which one would you rather have? That one. That's exactly right. And why? Because the decimal place makes a huge difference, right? It makes a really big difference. So if you happen to misplace the decimal, it makes a lot of difference in the amount of money that you have.
Yeah.
I guess I'll go ahead and take that one if you got the other one. Nice work. Well done.
There you go. Just wanted to get the importance of where a decimal point goes and why it is important. Right now, we're going to go to the phones, and we have Katrina on the line. Katrina, how are you today? Hello, Katrina. I think we've got Katrina coming in just a moment. Katrina is a 7th grade student at Tevis. And Katrina, how are you today?
I'm good.
And you're in 7th grade, correct?
Correct.
All right. Have you phoned in to do the math in the past?
Yes.
All right. I thought you sounded a little familiar. So, Katrina, as soon as you're ready, let's hear the math problem that you're working on. And Rhea, you can come on over here now. We're not going to make you do that 7th grade work. You can watch with me over here.
The instructions for the problem say, determine whether the relationship is a proportional relationship. If so, write an equation for the relationship and tell what each of your variables represents. If the relationship is not proportional, explain. Ty takes 1 hour to read 35 pages, 2 hours to read 70 pages, and 3 hours to read 105 pages.
Okay, so we have 1 hour for 35 pages and 2 hours for 70 pages, and the last one was 3 hours for how many pages?
105 pages.
105 pages. Okay. And we have to figure out, it sounds to me, if this is proportional or not, right?
Correct.
Okay. So tell me a little bit, Katrina, about proportions. What do you know about proportions?
Not much. Our teacher didn't really explain.
If you had to write a proportion somewhere on your paper or on your homework or somewhere on a test, what kind of form would that number take? Would you put it in a decimal? Would you put it in a whole number? Would you put it as a subtraction problem? Would you put it as a fraction? What would be your choice?
Fraction.
A fraction. Okay, so let's have some fractions here. So we have one fraction. Let's look at the very first thing you told me. You said 1 hour and 35 pages. So we have two things we're talking about here. We're talking about hours and we're talking about pages. Which one would you like to put on top?
Pages.
Pages, okay. So 35 pages on the top and hours on the bottom, is that okay?
Yeah.
Okay. And 1 hour. And then we want to know if this is proportional. So here's the deal. We're not going to look at any other of the numbers yet. We're going to go ahead and see if we can work with just these numbers here. If you had 1 hour and you read 35 pages, what would happen if you went at the same exact pace for the next hour, right? After 2 hours, the first hour you do 35 pages and the next hour you do 35 pages. And so what would happen? How many total pages would you have read after 2 hours?
70.
70, you got it. So we're not even looking at that stuff over there, but so far it's looking pretty darn good. That's exactly what you told me, 2 hours and 70 pages. So let's look at one more here. We have one more. It says we're going to go for 3 hours now. And we want to go ahead and see what's going to happen for 3 hours, even without figuring out if it's the number that you gave me. So 3 hours on the bottom. We'll take that same 70 you gave me, and remember, every single hour, you go back to the beginning information you gave me, you said every single hour we're going to read 35 pages, so we'll put another 35 in there. Can you add those two together for me? 70 plus 35?
105.
105. Good guess, just in case you didn't see it. It's right there. So look at these proportions here. This worked out wonderfully well because the numbers that you gave me are exactly the same as the numbers that were at the beginning of the problem. So, question for you, are these three things that you told me, are they proportional?
Yes.
They are. They all work out nicely. And we don't have to necessarily do the problem, but I'm curious to know if you had to go 1 more hour, right? If you had to go to 4 hours, how would you get to the next number of pages on the top?
Multiply 35 times 4.
Wonderful choice. 35 times 4. And if you had to go 17 hours, what would you do and how many pages would that be? 35?
Times 17.
Times 17, that's it. So however many hours you have, you would multiply it times that number of hours and you'd get your final total. Well done. I'm very impressed with your work there.
Great problem right there, Katrina. And because you phoned in today, we were able to do that one on air. You automatically have received yourself a ticket to the Kern County Fair. A 1-to-1.
Yeah.
Right there, that ratio.
That worked out well.
Anyway, hey, we do have phone tutors available until 5:30. 636-4357 is that phone number. Don't forget, phone number is also toll-free in outlying areas of Kern County, 1-866-636-6284. We'll take a look under the camera. Here's an example of the stickers that the County Superintendent of Schools office has sent out to all of the different schools in Kern County. And if your school has not received any of these yet, or the binder dividers, or the posters, or the variety of other things that are passed out to every single school, simply let us know. The phone numbers are at the bottom of your screen. Just call us up, say, hey, listen, I know we've seen these stickers in the past, and I put it on my binder last year, but I've got a new binder, and we don't have our stickers yet for whatever reason. So all you need to do is simply give us a call. We'll send out as many stickers, binder dividers, posters as you would like to your schools. Also, last week and this week, we were fortunate enough to work with some students a couple of weeks ago from Elk Hills School.
Right.
And we have an opportunity to go out to a bunch of different schools throughout the year and work with some students there. And then we can put those kids on the Do the Math program. If you would like Do the Math to come out to your school, all you have to do is talk to your principal, your math teacher, see if you guys can work it out. Give us a call on a Tuesday or Wednesday, and we'll see if we can get you in there. We are waiting for another call. I think, do we have Thomas ready right now, or Eric? I think we have Thomas ready now. All right, we do have Thomas ready. Thomas, how are you today?
Good.
What grade are you in?
5th.
All right, as soon as you're ready, let's hear that math problem.
I'm ready.
Go.
Wait. What's the problem?
You read the problem. Okay, so the way I've got it here, what you've told them is you have 26 employees. and $410 per week.
Yeah.
And it says after 1 week, he has $162.
Okay, yeah, because he paid them all.
Right, so you don't have this on something, I take it?
I have some paper.
Okay.
Scratch paper.
All right, so you're able to see the program, right? Oh, no, you can't see it either. All right, so here we go. This is going to make it fun. All right. So we've got 26 employees.
Yeah.
$410 per week.
Yeah.
After 1 week, you have $162. So you have $162 after 1 week.
Yeah.
Okay, now was there a problem you needed to do here? What do you need to solve on this problem? Or do you want me to come up with something for you?
I need to find. I think I need to find out how to divide 162 evenly.
So you want to take, keep going.
Wait. Yeah. I have to figure out how to divide 26 evenly with 410.
So you've got 26 employees and you need to get that $410 out to the 26 employees, is that it?
Yep.
All right, let's go ahead and do that.
Sounds good. So what kind of a problem are we looking at there, Thomas? You said we had to get this money out to each of the employees. Is this add, subtract, multiply, or divide?
Division.
Division. Okay, so I'm going to set it up for you. You tell me which number goes on the outside and which number goes on the inside.
26 outside
Okay.
and 410 on inside.
Well done. Okay, here's your first step. How are you going to go about dividing this? 26 goes into 4. Does it go into 4 at all?
No, so I have to move over to 41.
Good idea. We'll look at 41. That's right. How many times does 26 go into 41?
Once.
Once. Let's do it. So I'm going to put a 1 up top, right over top of the other one. And 1 times 26, what do you got there?
41 minus 26 equals.
Got to do a little borrowing from that 4, huh? So we borrow from the 4, 11. Wait. Go ahead.
15.
15. Good job. And I'm going to bring the 0 down. Would you agree with me?
Yeah.
Okay, now we have a really interesting problem. How many times does 26 go into 150? Let's do a little estimating in our heads. How about that?
Here's what we're going to do, Scott.
Okay.
This is going to get a little involved
Sure.
going on here. This is going to be 15.769.
Okay.
And there's going to be a lot of other numbers after that, but we're going to cut to the chase here.
So Thomas, we love calculators, and that's how we got that number for you. We saved you a little bit of time. So this is the number here, right? And this is dollars because it said we needed to put, we had $410, right? So $15.769. What should we do with that number? Should we do some rounding?
Yeah, I guess we could try rounding.
Good idea. Let's round this one to the nearest cent. Tell me which digit is in the cents position, or the in this case, the hundredths position.
For 26?
Yep, the 6, that's right. And the number next to it is the 9. Is the 9 going to round the 6 up, or is it going to stay the same?
Up.
Up, that's right. So I'm going to write your new number over here. And we're going to have $15, that's going to stay the same. And we're going to have the 7 is going to stay the same, and you told me the 6 is going to round up to a 7. So $15.77.
And Thomas, that's what we're going to leave you with right now, $15.77. And then if you think of there's something else you need to do with that problem, give us a call back because we do have phone tutors available until 5:30, okay? All right, great deal. And you know what? You are going to the Kern County Fair as well. And you know what? I think we've got about 3 more minutes, Scott, for you to work with Eric right now. So we're going to go to the phones with Eric, our last phone caller of the day. How are you this afternoon?
I'm cool.
What grade are you in? Okay, so you can't see this right now. So let's go ahead and hear what you're working on.
Okay, I'm going on Google.
Okay. Read the problem.
Okay, the problem is determine whatever the relationship between the two quantities shown shown in each table are proportional. By graphing on the coordinate plane, explain your reasoning.
Okay, so Scott, here's what we're going to do. You're going to come right over here and work on this.
Okay.
Because I've got it already written out.
Oh, great.
And we'll just move it up and down a little bit, but I think what we can do is we can basically get this right there.
Oh, wonderful. All
So
right.
let's go ahead, because you've got about 2.5 minutes to work on this problem.
Okay. Gotcha. So we have this graph here, right? You said it was on a coordinate plane.
Yes.
And you said that we have a chart here. It looks like 1 week is 125, and 2 weeks is 150, and 3 weeks is 175. Are those numbers corresponding with what you have?
Yes.
And then it said we want to figure out if it's proportional. Did you see that last problem we did with proportions? Proportions were in fractions, right?
Yes.
So we want to see if that's going to happen with this problem here. I really like the fact that we have a graph. What kind of shape do all the dots make when you connect them on this graph?
They
Look at your graph. What kind of shape are all the dots in?
It's a square?
Almost. There's a whole bunch of squares on the page, right? But if you look at that graph that you have and you connect the dots, do you see it's a completely straight line?
Yeah, wait.
So that's kind of nice. It's nice to have a completely straight line if you want to look for proportionality. Now next to that, I'm going to go ahead and start to write some of these fractions. We're going to keep the weeks on top and the amount on the bottom. 2 and 150. 3 and 175. So
we'll give you guys 1 minute to wrap it up.
We can do this. Here we go. Ready? If you go from 1 to 2, how far do you go up? What are you adding?
We're adding. Wait.
From 1 to 2.
1.
1. That's it. How about 2 to 3?
You're adding 3.
Adding 1. Almost. Plus 1. Plus 1. Do you see how we're going up 1 every time?
Yeah.
How about look on the bottom? From 125 to 150. How much are you going up?
From 125 to
25 to 150? We're adding 25. Do you see that?
Yes.
And then what about 150 to 175? How much are you going up there? Think about $1.50 and $1.75. How much did you go up? 25 is what I thought I heard you say. So if you continue to go up the same on the top and the same on the bottom, then we do have a proportional relationship. And the best way to describe that is the fact that we had a straight line on the top. So it's nice to have a graph on that problem. Thank you so much for calling in.
Nicely done, Eric. Congratulations. You as well are going to the Kern County Fair. And Rhea, since you did excellent work today, you are through working, except you need to figure out who's going to the Condors from all of the students that phoned in today. So pull one of those cards out, and who is that?
Eric.
That is Eric, student from Chipman right there. So congratulations, going to the Condors as well. Hey, we have phone tutors available until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.